we integrating? It's between those two, right? So you're looking at this region right here. Now this, you're right, we technically have not discussed this, but I bet you could figure it out. So how do you go about doing that? No Riemann sum. Integral. Yep. What should we find first? The points of intersection. You really need to find that point and this point. They're going to be, what's the relationship between those 2 points? They were reflections of each other, right? So you're looking for when 20 over 1 plus x squared is equal to 2. So x squared has to be 9. So x is plus or minus 3. So what integral you need to integrate? You need to integrate from what to what? Negative 3 to 3 of, did they call this something? Oh, they didn't. So it's going to be 20 over 1 plus x squared minus what? Minus 2 dx. Is this a calculator or non-calculator section? What? Hold on. What does it say at the top? Millions of ways. Millions. What is this? What is that? 12. Thank you. This right here is, so it's going to turn into minus 12. That's correct. What is the integral of 1 over 1 plus x squared? What is the integral of 1 over 1 plus x squared? Tan inverse. So this is 20 times tan inverse of x from negative 3 to 3. That's correct. So this is 20 times tan inverse of 3 minus tan inverse of negative 3 minus 12. Now what do you have to use? Let's write down all. It turns into 37.9618309. So what answer do you need to write down? What answer should you write down? There's 2 possibilities to get the full credit for the answer point on this. 37 point. How many decimals do you have to round to in the AP calculus system? I have said this. 3. So what's the answer? Or 37.961. That's correct. Either one of those will give you full credit. Let's just check that for a second. You get math. Math, what? What 9 is? F-int, right? It's 9, right? Yep, 9. And then what do? You do math again, right?
No.
Oh, sorry. Vars, right? Vars. Y vars. You select the first function, right? Comma x, comma 3 to 3. That's correct. And then you hit enter. It thinks for a little while. Because is it doing this algebraically? No, it's not doing this algebraically. It's doing an estimate. So we then take this. Hey, look. Now, what should you use with this? You're going to have to calculate. Do you have any idea how to do this by hand? No. Because even if you did use substitution, you're like u equals the square root of t. Is it going to cancel with that t squared? No, you're going to. Does parts even work on this?
I think it does. It does eventually, but it's really.
You like messed up, and should you ever do that? No. If this is a calculator section, which it is, what should you use? Use your calculator. Use your calculator, and we'll steal Bissell's flowing. So r of t is going to be defined in 2 ways, right? It's going to be that minus what from 0 to 3? Minus 250 from 0 to 3, and the other one's going to be 100 t squared sine root t minus what? Is it 2,000?
Yeah.
2,000 from what? 3 to 7. And they don't, do they? I don't think they, yeah. It's containing 0. This is right like this, sorry. So those are the rates. So what do you need to actually just look at?
Where?
Look at the graph, right? And find out where it's what?
Below.
Below, right? So you graph, first you graph this one and see where it's negative, and then you graph this one and see where it's negative. Do you have anybody have a faster way? Are any of those inequalities, should they be equal? No, because if it's equal, is it what's going on at those exact times? What's r of t equal to? 0. Is it decreasing? No. Is it increasing? No. The question is asking, when is it decreasing? Give reasons for each answer. You would say this because of this right here. There's your answer right there. Does that make sense? And maybe not say purple, you could say the actual function, because you're not going to have colored pencils.
That's what you think.
That's what you think. Yeah. So second, enter, like this. Second entry, second. It doesn't go back that far, does it?
Does.
Oh, it does?
There
Oh, there you go. Thank you. So we're going to go from 0 to what? 0 to 3. Thinks. And are we going to get something? We got something, right? So it's going to be 5,000, right? Plus, second answer, minus what? 750. We end up with, oh, is that greater than our first point?
Yep.
It is. So this thing gains a little bit. This thing gains a little bit. Does it gain a whole lot? No, not so much. Not so much. So this was, and does it say, always check to get your answer point, does it say to round to anything?
No.
So what do you, does it say the nearest gallon? So it's going to be 5,120 gallons. Yes. Let's just see if we got that answer point. The first step is really just, can you read a table? That's it. Can you read a table? Okay, so what does this tell us? It says, explain why there must be a value of r between 1 and 3 such that h of r is -5. Why?
Since it goes from 3 to -7 and it's continuous.
Yes.
right?
No, but how continuous?
Because it's differentiable for all the points.
Does it, hold on. Does it say h is differentiable?
F and G are differentiable, therefore H.
Yeah. Okay. That's correct. H is continuous since it is the composition of what?
F and G
Of two what?
are differentiable.
You can say that. That's totally fine. Two differentiable functions. Yes. Okay, so it's continuous. So what does that mean? What does that mean? Just if you had to explain it to someone in like Algebra 1, because it's continuous, what does it have to do?
Contain all points between 3 and -7.
H can't do, what can't it do?
Skip over.
Can't skip over any y values. Well, to skip over any values, right? There's no holes in it, right? So it must pass through. So on a, I like this, journey from y equals 3 to y equals -7, h of x must pass through what?
All points.
Through all points, and therefore through what?
-5.
Through -5. That's right there. That's fine. That's if you have a function that's continuous on the closed and differentiable on the open from between 2 points.
Yeah.
The slope between the two can be found as the slope of the tangent of at least one other place. Could there be more than one? Yeah. Do we have any idea what h does at every other point? No, we only have a few, but we know at least once. At least once. Say it louder. The fundamental theorem of calculus. What does that tell us it is? W prime of x is going to be equal to f of what? G of x. You're doing the derivative, right? Times what? Times g prime of x. That's, no, the 0 is, the 1 is irrelevant. Remember, the constant doesn't come into play. We're not integrating it, right? What are we doing? We're taking the derivative, but it's not x here. What is it?
G of X.
G of x. So instead of plugging in x, we're plugging in g of x. But because we're plugging in g of x, we have to actually think about what rule? The chain rule. Usually, if it was just x, what are we kicking out if it's just x? dx dx, which is 1. But we're not kicking out that. We're kicking out g prime of x. So they want w prime of 3. What is that? W prime of 3 is going to be. Now what are we back to doing?
But then when you look at the table,
We're looking at the table. Exactly. What's g of 3? Do you have it? Can you just tell me what it is? You guys have it. What's g of 3? 4. And what's g prime of 3? Times 2. What's f of 4? That jerked around. What is it? -1 times 2 is -2. So again, this is the setup I can guarantee is worth a couple points, or at least a point, and then the answer is worth 1. So this is worth at least 2. Let's check it just to see how we did. 0. Okay, good. So you did 1 endpoint, it comes out to 0. Okay. And what about x at 2 pi? E to the -2 pi sine of 2 pi is going to be 0. So it starts and ends at 0. Okay. What now? Yeah, we want x prime of t. And what do you have to use? Product rule. The derivative of the first times the second plus the first times the derivative of the second. And we want to know when the derivative is equal to. So we want to know when negative sine t over e to the t plus e to the t over cosine t is equal to. Oh, it's not e to the t over cosine t. I'm sorry. I did it wrong. Sorry. E to the negative t cosine t is equal to 0. Is that correct? Why is that a good? Why is this a nice thing to have? This setup right here. Yeah, this right here can never be what? Yeah, this right here is always never equals 0, right? So we're only looking at when cosine t is equal to. What should I divide both sides by? Now let's try cosine. I like tangent better, right? So what do you end up with? Tangent t is equal to what? 1. So what's the tan inverse of 1? Pi over 4. The tangent of what is 1? It's pi over 4. Are there any other times when it's equal to 1? Plus pi. You get 5 pi over 4. Yeah, but we're only inside. We have to be less. It has to be less than 2 pi greater than 0, right? So here are two places, right? But that's just where the derivative is 0. What does that tell us?
That there are critical points at those.
Those are critical values. Does it tell if it's a min or a max?
No.
Or does it have a max?
Nope.
No. So what do you need to do? First or second derivative test. Correct? So we have 0, pi over 4, 5 pi over 4, and our upper boundary is 2 pi. So this is the x value. We need the, that's the t value, sorry, not the x value. It's the t value. I don't like it when they label functions x. The x prime at that value, right? What is the derivative? The derivative function is this thing, right? This is always, it's not only not equal to 0, you know it's what? It always has to be what? It always has to be positive, right? So this right here entirely dictates the sign of the derivative. So you could say the sign of the derivative, you're just looking at what? Cosine t minus sine t. Correct. Do you have a calculator for this?
No.
No, you don't have a calculator for this. So what might you need to, what's our, but we have done the first derivative in the, yeah, what was the first derivative? It was e to the negative t times what? Did we factor out a negative? I don't think we factored out that negative. It's cosine minus sine without the negative out front, right? So it's going to be, if it ever goes away, cosine t, and I'll get that in a second, sine t, and that negative is not there, right? It really doesn't want to erase for some reason. I don't know why. Oh, there it goes. There we go. Okay. So now, and then we have, what's the original function? E to the negative t sine t. Is that correct? Can you tell me if that's right?
Yep.
Okay, it is right. Okay. Good. So at this point, what do we need to find? The second derivative. We need to do that second derivative. So we really hope our algebra is okay, right? We know that this has to be always greater than 0, right? So what are we solving for? Negative 2a cosine t plus cosine t is equal to? Is equal to 0, right? So we have, yeah, cosine t is equal to 2a cosine t. So what do we get? 1 is equal to 2a, so a is equal to?
1/2.
Is that freaking beautiful?
Yeah.
Yes, do we hope that's right? I'll keep this on recording. What do we think here? What do we think?
Hopefully.
Woo! Did we just get full credit?
Yep.
And look at what they constrict it down to.
You
They
lied.
just it and they're like, yeah, do it.
Screw you.
Yeah, exactly. So we got full credit. That's good.